Welcome to BSc Statistics students. In this lesson, I explain one more problem in critical path method CPM. This is problem number 4, right? So these are the activities are given here and time duration in months. It was specified. And what are the predecessor activities to these activities? It is also specified here. You have to construct network diagram and critical path. But of course, by using this, we have to calculate the minimum duration of completion of the project. Right, all these points we have to calculate. I'm sorry. So now we consider an activity. Already we have discussed the activity, which is by joining two particular events, we get an activity. So this is an activity A. The predecessor for A is no particular activity, no predecessor activity for A and B. And for C, the predecessor activity that is before C, A should be finished. That is called predecessor activity. An activity which should be finished before another activity, before starting the another activity. So that is called predecessor activity. Before D, the B should be finished. E, like that, these are all given. Now we have to see what are the activities which are starting activities, which has no activities have no previous activities, predecessors. So A and B, and similarly, what are the activities or and activities? If you see here I, there is no and activity after, that is this is an and activity. There is no other activity after I. And similarly the H, these are two and activities. After H no activity, after I no activity, right? So basing on this information, we have to start the construction of network diagram. So I'm writing here network diagram. Basing on these conditions, we construct the network diagram. A and B, two starting activities which have no predecessor activities. So therefore, I'm constructing A and B first of all. For example, I consider this is event 1. Then I'm considering A in this direction. So let it be, this is an event 2, so that A is going to be formed. Duration is for A is 4 months. Similarly, I am considering another activity B. Okay, right? Another activity I am considering B. Let it be third event, and so that you construct another activity B. The duration is for B is 6 months, and then you see remaining relations. And before C, A should be finished. Before D, B should be finished. So after A, I'm drawing another activity C, and after B, I'm drawing D, right? So another activity I'm considering from here to somewhere. I don't know whether which is the activity is going to be started there. C, this is activity C. This is what the duration for C is 8 months. And thereafter you see the relations. After B we have two activities. After B, D is also there, E is also there. That is for D and E activities, predecessor activity is B. That is now we have to construct in the fashion that after B we have D and E. D and E. So I am considering another activity D here, and I am considering one more activity here. And I'm considering this activity is D. The duration is for D is 7. Am I right? Right. And duration for, I am considering this is an activity E. Hope you understand. D and E are two other activities which are to be started after B. The direct connections have given here, and for E the duration is 4, right? And then I'm considering like this, and I see the remaining relations because I have not considering D with not too much of length, because one reason, because you see here D is an activity, it is to be finished before starting the activity F. That is for the activity F, D is a predecessor. D should be finished before starting F. So after D we have another activity called F. Okay, and so therefore I'm constructing F here. So somewhere here I'm considering F, the activity. I give you the numbers, and this is what the activity F I'm considering. F is the time duration is 6 months for F. Okay, right? And then that I consider whether any relation between G any relation between E and F. No. So therefore we can proceed. And then now you see after E, G, the activity G should take place. So that is before starting G, E should be finished. What is E? This is what E. Okay. And also now we have to see any kind of relation between the H and G. So that is important before finishing this. Yes, we have a relation. That is, I'm not constructing G. I construct G after the activity E. We have to construct the activity G after E. Okay, this should to be in this way. So after E, we have two particular events. After E, we have G. After E, we have I. The two activities are which are going to be connected like this. I is an independent activity, and so I'm constructing like this. Independent activity. So this is what the activity I we can consider. The time duration is 10 days, and we have to construct. We have to consider the activity G. Maybe it may join here, but we have to see and decide. The H is an activity which is to be finished, which is to be started after C, F and G. So therefore we got a clear relation. This is what you see here, C, F and G. Is it clear? C, F and G, the three activities which are to be finished, and then H is going to be started. So therefore we have one option here. That H is an AND activity, of course. That is also one particular possibility. And CFG, you see here, where is CFG? C is here, F is here. Definitely we can go and end this particular activity here up to here. So therefore I'm drawing here a clear line which is going to be connected to F. So this is C and this is F. And this is G. G I am considering here, and so that G is also finished. G is also finished here. The time duration for G is it is 5 days, 5 months. I'm sorry, 5 months. And finally we have one activity is called H. That is H. I am considering it is an AND activity, independent activity. Therefore, I am considering H here. Then the time duration is 19 months. Now the diagram was finished. You see here, before H, starting the activity H, C, F, G are to be finished. You see here, C is finished here, F is finished here, G is finished here. So that, and then H is started. This is what you have to look after, the relations between one activity to another activity. You have to observe the relation and then you have to draw the diagram. And I see all the relations now. Before A and B, there are no activities. So therefore, predecessor activities are not there. You see here we have constructed in this way A and B, and then that is before C, A should be finished. Before D, B should be finished. Before E, B should be finished. That is before C, this is an activity, A is finished. Before starting the activities D and E, that B should be finished. That is after B, D and E activities took place. Activities are going to be started. That is D is directed here and E is directed here. And then we have to consider before starting the activity F, you have to finish D, and before G, E should be finished. Before F, D should be finished. This is what before F, D is finished, and before G, before starting the activity G, E should be finished. This is what G, before that E was finished. Right, clear? And then one more relation, two more relations here. Before H, C, F, G are to be finished. Predecessor activities. Before H, C, F, G are finished. Therefore, it is right. And then before I, E should be finished. This is what before I, E should be finished. E was finished. Right? Now I give you the numbers 1, 2, 3. It is 4. I consider this is 5 and this is 6 and this is 7. Right? 4, 5, 6. And these are the values which are considered in the construction of the network diagram. So now I have to calculate. The values of E's and L, earliest times and latest times. I am considering here E1 is equal to L1 is equal to. Okay, right? And E2, L2. And E3, L3. And E4, L4. I consider E4 here, L4 here. And E5, L5. E5 and L5. E6, L6. And then finally, for last node, E7, L7. Right? Now I start the forward pass calculations. By using forward pass calculations, I calculate the earliest times, E's. Okay, but I consider for first event E1 is equal to 0, and then you see you go to event 2, calculate E2, only one connection, one connector, so 0 plus 4, it is equivalent to 4, and then you come to the move to the third node, third activity. And the third activity we have only one connection, one connector, the 1, 2, 3. So therefore you calculate 0 plus 6 is equivalent to 6, and then move to the fourth event, that is E4. So again we have only one connection, one connector, 6 plus 7, 13, and move to the fifth node, fifth event. Here it is the fifth one. We have only one connection. Then we have to calculate E3 plus D3, 5, 6 plus 4, 10. And basically now move to the sixth one. Now we have three connectors, 2 to 6, 4 to 6, 5 to 6. Therefore, you have to calculate the maximum value. You have to consider maximum value. 4 plus 8, E2 plus D2, 6. That is 4 plus 8, 12. You write here. And coming from 4 to 6, E4 plus D4, 6. E4 is 13, D4, 6 is 6. 13 plus 6, 19. And then E5, 5 to 6. E5 is 10. E5 is 10. 10 plus D5 6 5, 10 plus 5 15. So the maximum is 19. Maximum is 19. And coming to the last one, that is E7. It is connecting with two connectors, that is from two nodes. It is going to be connected 6 and 5, 6 to 7, 5 to 7. So therefore you calculate again two values and take maximum. E5 10, 10 plus 10, that is D5 7, 10, 10 plus 10 20, 20. And then from 6 to 7, E6 19, 19 plus D6 7, 19, 19 plus 19 38. The maximum is 38. So therefore E7 is equal to 38. So this is what the calculation. The calculation, forward pass calculation, and we have calculated the values of E's, that is earliest times. So now I am calculating backward pass calculations. By using the backward pass calculations, I calculate the values of L. Now we have to start from the end node, seventh node or seventh event. Now you have to come back. What you have to consider from the last node, that is for the last node, you have to consider E7 is equal to L7, E is equal to L. So 38. We have considered L7 is equal to 38. Coming back to 7 to 6, we have only one connector. So therefore 38 minus 19, L7 minus D67, it is 38 minus 19, it is 19. Okay, right? And then move to the fifth one. The fifth one, it is going to be calculated L5. It is connected with two connectors. So 7 it is coming back to the 5, and 5 to 6, that is from the sixth event also we have one connector. So therefore we have to consider minimum. Calculate the value Lj minus Dij, minimum of Lj minus Dij. Here 38, L7 minus 10, it is 28. It is 28. And then coming to 6, coming from 6, 19 minus 5, it is 14. So minimum is 14. Clear? This is what L5. And then coming to the after 5, 4. This is what 4. We have only one connection. So it is 4 to 6. Connection is from 6th event. L6 is 19. D4 6 is 6. 19 minus 6, it is 13. It is 13. And coming back to the third event, this is third event. And so what you have to do is how many connectors? 2. 3 to 4, 3 to 5. That is 5 to 3, 4 to 3. Which means you have to calculate L5 minus D35. 14 minus 4. 15. 14 minus 4. It is 10. Okay, I write somewhere here. 10. And 13 minus 7. It is 6. So therefore the value is 6. The minimum value is 6. And coming to the second node, that is second event, it is connecting with only one particular connector from 6 to 2, that is 2 to 6. L6 minus D26, 19 minus 8, it is 11. It is 11. So, and coming back to the last, that is first node, that is last value, L1. It is connecting from 1 to 2, that is 2. It is coming from, coming from 2 and 3. That is 1 to 2, 1 to 3, the two connectors to calculate the L1, the first at first event. 11 minus 4, 11 minus 4, it is 7, and 6 minus 6, L3 6 minus D13, that is 6. That is 0. 6 minus 6, minimum is 0. Hope you understand. These are the calculations for latest times. These are backward pass calculations. So in this way you have to calculate forward pass and backward pass calculations. So therefore with these calculations what you have to observe, you have to calculate, you have to find a critical path for which you have to identify critical activities. What are the critical activities for which activities and for which events? E is equal to L, then which are called such activities are called critical activities. There you see first of all. E1 is equal to 0, L1 0. Of course, it is true for all. And E3, E2, L2 not equal. E3, L3 equal 6. So therefore, you directly can take the this activity into critical activity, and this activity is to be connected in the critical path, right? And then E6, E3, L3 are same at third node, and E4, L4 also same at fourth node. So therefore, 6 plus 7, 13. It also can be considered in the critical activity, in the critical path. It is considered as a critical activity, and it is to be included in the critical path. And then F, the activity for which 4 and 6, E4, L4 are equal, E6, L6 equal. Therefore, it is also treated, the activity F is also treated as critical activity, and it can be considered in the critical path. And then E6, L6 and E7, L7, which are also equal. Therefore, we can consider this activity into the critical activity. Therefore, the critical activities are 1 to 3, 3 to 4, 4 to 6, 6 to 7. Therefore, the critical path is the answer for the critical path. Critical path, therefore, the critical path is 1 to 3, 3 to 4, 4 to 6, 6 to 7. So, this is what the critical path. It is going to be considered. And then the duration, of course, simply we can observe the value of E and L, that is E, just you observe E at the end activity, it is called total minimum time duration. The minimum time duration is 38 days. 38 days, not days, months. It was given in months. So 38 months. To complete this entire project, it takes 38 months. So this is what the problem. Hope you understand. You have to construct the critical path. In this critical path, we have to construct the network diagram, and then forward pass calculations and backward pass calculation. By using this, you have to calculate earliest times, latest times, and then critical activities you have to obtain, you have to find out, and then critical path, and then minimum time duration, minimum time to complete the project. Fine. Hope you understand. Thank you.